to tell that what are the possible number of decoded strings for that. So for a specific string of numbers, I have to tell you that okay, we have a string S which has only digits. I have to return the number of ways to decode it, which means convert that back to a string. And for sure, please make sure that 06 is not equal to F. 6 is equal to F, but 06 is not valid for us. So 0 as a starting, you should not consider this. Please remember this case because this will be a pain in your ass, which means you have to handle this edge case specifically for you every time you have to go. Now, as simple as that, we will take any example. You can take any example and just try to replicate that what all possible decoded strings you can have. So in general, I just took this example, like this exact same example, and I simply added a 1 into it just to make a bigger example. Now you will try to just replicate the example itself and try to figure out what all possible ways should be there. So as you have the string 1 2 6, so you will firstly grab a single one. Now I am at this index. One option with me is I can grab a single one. Other option is I can grab a 1 2. Right? Okay, when I have grabbed this, I will move on to the remaining portion. Okay, when I say I will move on to the remaining portion, now again I have two options. Either I can grab a single 2 or I can grab a 22. Okay, when this is grabbed, again I have some remaining option, so I can grab a single 2 or I can grab a 26. So you see that every time I have two options which I can consider. So firstly, at the very basic thought, as soon as you have seen and you have just figured out, okay, at every ith index I have two options. Either I will take the current index, or basically the current element, or basically the current number, and I'll go on simply move on to the next number, or I can just club the I and I plus 1 as a specific number, and then I can simply move on to I plus 2. These two are the options with me. Again, we are just seeing options. We have to still verify that the number formed is actually less than 26. We have to still verify that this character is not a 0. We have to still verify that this character is not a 0. So there are certain verifications we had to do which actually make this problem a bit tricky than the standard medium problem. Now, okay, but the basic thought we have got, okay, we have two options. Either we take this one element itself, or we take two elements which are basically to just make a number which is of 2 digit. We can do that, and thus we can have a rough idea. Okay, we can have two options, and every time you can see we are building a tree having two options. So ultimately there can be a chance we can have a repeating sub problem. So for that repeating sub problem, I can just say, as you can easily see that, okay, if I just ask you for 1 2 2, how many number of ways are there? So you can see 1 2 2 this portion, entire portion, 1 2 2 this entire portion. So you can see we have a repeating sub problems. So recursion is for sure there, repeating sub problems are there. So you know one thing for sure, that you will apply your DP, which means you will simply apply a top down DP. Now let's come back and now verify that how you will write your DP. We have base cases in the DP, we have prime conditions in the DP, and simply we have the conditions for memoization. Memoization condition is simply easy. We can just initialize any of our data structure on our map vector, and then we can just have a quick check. If we have got the values, it's good. Simply return that. If not, then just go to the recursive function. But the prime things are the base cases and stuff. Now, considering that we took this example 1 2 2 6, so as I told you, at this index I had two options. Either I can take this index, which means I'll take this specific value itself 1, and I'll try on for I plus 1, or I said I will just club I and I plus 1, which means starting from the index I for length 2, I will get it, and then I will make a number. I make a number out of it. But as I showed you, I will have to, okay, I started with the index I took the length of 2, I converted that to a string, I converted that string to a number, and checked it should be less than 26. If it is, then okay, it should be like, or it is a valid, it can be converted to a valid alphabet, right? Okay, so when I take 2, I will have to verify using this condition, which we also discussed previously also, and then I can go on to I plus 2. Now bhaiya, for the one element, can I just simply go on and move on to the next element? Yeah, you can, because for sure it can be from 0 to 9. It can be from 0 to 9, can be any number from 0 to 9. Bhaiya, but 0, you remember something bhaiya? 0 0, you said that you have to make sure. Yeah, exactly. So if your ith element is actually a 0, so simply return a 0, because it will have no ways possible to have, because at ith index, if it's actually a 0, so for sure you cannot have 1, as the, because your encodings itself are starting from 1 itself, so you cannot have any encoding for 0 itself. And also, what about 0 3? Like if we club 2, still 0 3 is also not valid, because as in this example itself was saying, 0 6 is not valid thing. So for sure 0 is not a valid encoding, and also 0 3 is also not a valid encoding. So basically at the index I, if I have a 0, bro, I am screwed up. I have to return a 0 itself. So that can be our base case, that okay, if the ith index is actually having a 0, please simply return a 0. Now if we just go on and simply drill down to say okay, when to return, because for sure we have just seen that the main recursive condition is I will try on for the index, and for sure if it is not 0, then I can try on for every values. I can simply go on to I plus 1. So one case is I'll simply go on to I plus 1th index and I can simply try on. Other is I will just have a quick check for string, like starting from the index I of length 2, if the actual integer is less than 26. So for sure this club 2 is also good, then I can also try for I plus 2, and then I know that I have to simply sum up the actual, okay, the options which I have from left side, the options which I have from the right side, just simply sum up whatsoever number of ways they are giving me. As you can also see, if we go back and look at the base example, so ultimately in the end, let's say I have made a valid string. Now we will see ultimately in the end what it means ultimately in the end, which means how to know it's a valid string or not. But yeah, if it's a valid string, so I can simply say okay, it is one string which is valid, 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 right? Now, so it will simply return this will return a 1 to upper thing, so it is one string. This will have one way which is actually 2 ways. So now this will return a 1 to him, so it is saying one way. It is also saying one way. It will return, it will say 2 ways, it will say 1 way, it will say 3 ways. So in total he will say 5 ways. So just saying okay, I am just adding the ways for my left and the right child, that's it. So similarly I will just have solve function which will get me the ways if I just go on to I plus 1, and solve function of I plus 2, considering here I check that the string, or basically the integer formed with the 2 digits should be less than 26. If that is, then simply add up. So that can be your recursive case. Considering these will be your recursive case. Now just having known okay when to end, bhaiya, this is one of the edge cases which I can handle while returning. But bhaiya, when to end actually? So for that, if we just simply go down a bit more, then we will see okay, if my I is here, right, if I have just one character left, then I'll go and try for I plus 1. Now if my I would have been here, so I would have just clubbed it and I would have tried for I plus 2. So basically you see that ultimately if pattern is something like this, then your I in the next iteration, your I will be here, which is in the end of the string, which is s dot length. And also if you have only one character left, and for sure if you have gone into your recursion inside, which means if you are inside, which means you have skipped this condition, which means the character, or basically this digit was not a 0, so it is some valid digit, which is one digit which is valid. So for sure if you have landed onto the last index, and for sure when you have landed here, which means you have skipped this, which means you have passed this condition, so the digit was not a 0, so for sure it's a valid digit also. So I can just say if my I is actually the s dot length, which means it is the last index, or I can say if my if I have passed the complete indexes and I have reached the super end, any which ways, if you have reached, then you can simply return a 1, which means you can simply return a 1, which means, okay, you have found a valid decoding you have found. So I can just simply write the exact same condition as I, if it is greater than or equal to s dot length minus 1, then simply return a 1. That will be my base case. Now simply have a quick look at the code. Exact same thing as I showed you. The first edge case which I have to handle is while calling my recursion, before itself, if my s of I is actually a 0, then simply return a 0. Okay, and the condition which I showed, the actual base case is if I is greater than or equal to s dot length minus 1. Again, I showed you s dot length minus 1. By combining these two base cases, I got this condition. This is a simple memoization condition. Although you can take the vector also, but here I took the unordered map. You can take anything just for memoizing your DP, and for sure the answer which you've got, you will simply put back in your DP itself. Now the actual recursive cases, as I showed you, it just has two cases, which is go and solve for I plus 1, go and solve for I plus 2, but go and solve for I plus 2 only and only when the integer form from the 2 digits it's less than 26, right? Because it, like, less than 26 represent a valid character for us. So I just say, okay, go and try for I plus 1, and also just go and check if the 2 digits are, like, if I combine them, so it should be less than 26. If it is, then simply go and try for I plus 2 also. And as I showed you, I'll simply add up whatsoever result I'm getting from left and the right side. And thus you will see, because how you know how to add the results, by just simply looking at the first dry run which we had, left side, right side. Simply if it's valid, simply return a 1, which our base case will return for us. And for sure, if it is a valid, then simply return a 1 and keep on adding the, okay, like from the left side and from the right side. So I'll simply keep on adding the ways from my left side and from my right side, or basically saying, okay, take the current index only and take the 2 indexes consecutively, and then you will get the answer. Okay, but it just a quick check that its time is actually over, because you are going on to all the indexes because of the memoization which you have done because of DP, and space is also O of n because you have memoized all the indexes. Now the interviewer will ask you, man, can you please optimize it? So what you will do, you will start optimizing it, but then you will think how to optimize. Like, now optimizations cannot be thought of for the top-down approach, which means for the recursive approach, memoization, it is a recursive which we have memoized. We cannot optimize these approaches. We have to convert this to a bottom-up. So we will use exact same logic and convert this to a bottom-up code. Again, exact same logic. Now just to write the exact same code down, we just have to know that, okay, I will just simply know that. And for sure, in top down, you just say, okay, I am at the ith index, and you just try for the future indexes, right? In the bottom up, you just say, okay, I am at the ith index, and I think that all my previous indexes are already calculated. That is how you go in the bottom up approach. Now I'll just simply say that roughly what I have seen from my previous answer is that my answer, which is the dp of I, is nothing but the sum of dp of I minus 1 and dp of I minus 2. That is roughly what I know, which is what I was adding. I was simply adding solve of I plus 1 and solve of I plus 2, right? Exactly same thing. So I'm just doing the same thing for bottom up approach also. But have a quick check that how will you handle the base cases, how will you handle that zero condition, all that stuff. So for that, I'll just simply have a quick check that what I actually wanted. So I took a very small example, very small, because base cases can only be found out with the smaller example. So take very small example, which means you take just one character, you take 2 characters, and so on and so forth. So very small example can help you get the base cases out. So I took a very small example, 1 2. If I have a 1 2, I will have just 2 cases. Either I can form a 1 2 or I can form a 12. That's it. Now if I form a 12, which means I have my index I here, right? Then I will say, okay, I minus 2, simply get me the ways for I minus 2, and I'll simply say dp of I is nothing but the dp of, okay, the base for dp of I minus 2. But you will see I minus 2 is nothing, it's an empty string. So with this fact, and you know the 12 number is valid, if this number is valid, so you will simply go and check for I minus 2. But I minus 2 is actually dp of 0 if your indexes are like this. Okay, index is 1, index is 2. So again, I am just marking it as 1 indexes. You will know why I am doing that, but I'm marking that as 1 indexes. But I'm just going and checking for I minus 2. If that I minus 2 dp of 0, which means 0 means empty string. Empty string is actually a valid case for us, right? Which means ultimately you saw that in the top down, in the top down, you were actually reaching the super end. Then you were saying, okay, it's a valid string. It's a valid string, which means you have surpassed. If I just go back and say, I have surpassed it. I have surpassed it, right? So I'm now saying I'm starting it. I'm saying now I'm starting it. It's a valid string for me. I have just one character. It's a valid string for me. So case is 1, simply return a 1, just making sure that it should not be a 0. If it's a 0, simply return a 0. So I'll write the exact same condition in these two forms right here, that I will say if my actual dp of I minus 2, which means my dp of 0, which means my empty string in the beginning is actually a one way for me, as my complete string was a one way. So my empty string is right now a one way for me, and from that I am starting to build my answer. Again, this edge case, or basically these base cases, make this problem a hard problem according to me. Else if you think it's easy problem, great for you. Now what about bhaiya I minus 1? Yeah, true. I minus 1 you also check, but in that you just check one character itself. So this one character you had. Now if this one character is a 0, if it's a 0, your value will be a 0. So dp of 1, again, that is 1, that is 2. Indexing is, let's say, 1 based. So dp of 1 will be a 0 if the character is a 0. But bhaiya, what if it would have been a 1? Yeah, if it would have been a 1, so you would have just said, okay, dp of 1 is equals to 1. So I just combined these three conditions, the two conditions right here, which means just saying I have only one character, I have no character, so simply return a 1. But only one character, only and only when if that character is not a 0. If it's a 0, simply return a 0. So these three conditions I combined in saying that if my character is a 0, simply dp of 1 is actually basically the dp of I is actually a 0. And if it is not a 1, like if it is not a 0, so simply dp of the first character, because base cases are just same, dp of 0 is actually a 1, empty string is a 1, dp of 1 is actually again a 1, considering that character which is s of 0, because you saw that I am saying 1 based indexing, but actually the string is 0 based. So dp of 0 is not equals to a 0, then I will say, if it is not equal to 0, then I will say that my value is 1, else I'll say my value is 0 for my dp of 1. So these two are the base cases for your bottom approach which you can have. Cool. And for sure, exact same thing that for dp of I minus 2, you will just still go and check that the number formed should be less than or equal to 26, right? And also you know that from this I and this I minus 1, you will try to build a number out of it, right? So just have a check that this value should not be equal to 0. So s of I minus 2, as I told you, I am saying for 1 based indexing. So for sure, s of I minus 2 is on the indexing based for the string. So s of I minus 2 should not be equal to a 0, and this value formed should be less than or equal to 26. So here I'll just say s of I minus 2 should not be equal to 0. Again, that is a 0 based indexing, because string is 0 based indexing, but I am just thinking of in the form of 1 based indexing for my dp to actually solve. An exact same thing which we have done for bottom up. This is how we can replicate for the exact same thing which we have done for top down, the exact same we can replicate for bottom up. Now if I just write that again thing down, so it is initializing my dp. Again, I just did it for n plus 1 because I know it will be a 1 based thing. dp of 0 is a 1, empty string, again empty string, saying it's a 1 way because I mentioned that when the entire thing is completed, when the entire thing Okay, where is it gone? Yeah, when the entire string is completed, it is actually a one way for me. So similarly, I just try to replicate my example and say, okay, if my indexes is here, so this is a valid string, so I minus 2, it will point here, so it will try to get the value of I minus 2. So this is saying I minus 2 is just nothing but dp of 0, so this should be a 1, considering this is valid. So no matter what it is valid or not, we will check have it differently, but if I am getting a dp of 0, so it should be a 1, and this string is valid, always valid for us. Now dp of 1, as I showed you, will be nothing but considering this character, if it is equal to 0, bro, there is no way, simply return a 0. If it is not, it is any other character, any other digit, okay, from 1 to 9, it is any other digit, simply return a 1. Now I have got these two base cases. I am very good to start off from I equal to 2, and for sure it is a 1 based indexing, so I'll go up till the n. Again, this is a 1 based indexing, which means dp is 1 based indexing, but my s is actually 0 based. So remember that if I am saying, okay, if I am at the index I and I want to access s of I am ultimately saying that I will be accessing s of I minus 1, right? It will be one less index which I am considering. So dp of I, which means at the ith index of my dp, I am actually thinking of s of I minus 1, which is the actual index for my string. So here you will see that for the ith index, I'll just check s of I minus 1. Again, for the ith index, it is the current index, it is the s of I minus 2 is the previous index, right? So remember that your string is 0 based. So this is a small thing which you have to make sure. Okay, I am at the I equal to 2, I is less than equal to n. Again, I will have only one check if that is not equal to 0, which means the current index value should not be equal to 0. Then I can simply add my dp of I minus 1 to my answer, and also I'll convert this number into, like, this two consecutive digits I'll convert into a number, and I will just check if this number is less than 26. Again this small check, if it is also, which means the s of I minus 2, which means the previous digit, should also not be equal to 0. As I showed you, if I am at this index, current index I, so I'm just saying this, if this is 0, okay, skip it. If the previous index also is a 0, so it's not a valid case, right? I minus 1. And when I say I minus 1, I am referring to s of I minus 2 in the string. S of I am referring to s of I minus 1 in the string. So with these two cases, I will just verify. So this is something which you always have to write down. And with this, you will just say, simply add that if it is not equal to 0 and your number is less than equal to 26, simply add that in your answer, which is dp of I. With this, this small piece of code will get you the answer, and ultimately your final answer will be stored in dp of n, because you're simply propagating all the values and summing up to the next dp of I. Now you can think of optimizing it. So if I just ask you, how will you optimize this? So the first thing which you will see is that to calculate dp of I, ultimately I want dp of n. Okay, that is good, but to calculate dp of I am only and only using dp of I minus 1 and dp of I minus 2. So I'm only using the previous two values. I don't need any other value at all. So I'll just do the same thing. Right now the time and space is exactly same as that of the top-down approach, but now I can think of optimizing, because I know it is super visible that I just have to use two variables instead of using this entire dp array. I can just use two variables, which one of which will be dp of I. So let's name it as current. Other variable will be dp of I minus 1. Let's name it as 1 back. And other variable will be dp of I minus 2. Let's name it as 2 back. 2 back, which means 2 backwards. It is a current, it is 1 back, it is 2 back. I just need 3 variables, and you can see also that I just need 3 variables. It is just being shifted. So I'll just use these 3 variables exactly to get the answer. So current state of my program code is looking something like this. Now I just have to remove these and modify them. I just have to remove these 3. I just have to modify that with the variables. So I'll just use 1 back and 2 back, as I showed you. Instead of, I'll not do anything at all. I'll just replace this and say it is 2 back, right? Because it is 2 backwards. It is actually 1 back. 1 back. It is actually current. Again, replace this with 2 back. Sorry, 1 back. replace this with 2 back, and voila. And for sure in the end you have to populate your 2 back value with 1 back, and also 1 back value with current, just to propagate forward. As you do, you just populate the values. So you just did only this modification to get the answer. So I just initialized 2 back, 1 back, exactly same. You will see 2 back, 1 back, right? Forget this condition right now. I just added this extra line, that's it. You will see why it is required. But then I initialized my current. As you saw that your dp was initialized to 0, and I was simply adding in my dp5, which means your dp5 was initialized to 0 always, right? So I just do the same thing. I just initialize my current with a 0. As you saw, I have replaced my dp5 with the current itself. So I'm just initializing my current always with a 0. Okay, I did that, and then I just did current plus 1 back, exactly same. Current plus 1 back, right? Exactly same for current plus 2 back, right? Exactly same. It was current plus 2 back, exactly same. And then when this entire portion is done, just simply assign the new 2 back and 1 back value. So I just assign 1 back to 2 back and current to 1 back. That's how I have got the new 2 back and 1 back. And then I'll just keep on continuing this loop. Ultimately I'll simply return my current, which is actually nothing but my dp of n, which is the current value, which I have updated. And that's how you can just use 3 variables. Now coming back to just one condition, why I have to add it, just for you to know that if I just have only one character, let's say just one character I have, so for sure it will not go inside this loop. So I will simply start returning my current, which is nothing but a 0 value. So it will simply return the current because it never went inside the loop. So I just have to add some condition that if it's just one character, simply return the 1 back itself, because my current is not even initialized. So how I can even return the current without even getting any of the other character? So it is just one condition which you have to add, and thus these small edge conditions make this problem a very good problem for interview, because interviewer will see how you are considering the edge cases. Again, it has so many edge cases, not so many, but to handle those edge cases, you just have the 0 case. You just have 2 consecutive characters. If you just get them a digit, it should be less than 26, and for sure adding the weights, which is dp of i-1 and dp of i-2. And that's how you can simply get this solved in O of n time and O of fun space. I hope that you guys got it. If yes, then please smash that like, baby. And also, if you have not watched the depression, if you are in depression and you want to get out of it, and you are saying, okay, if I'm only one in the depression, you can just go and watch the video of how to get out of depression if you're doing Leetcode for so long. Cool. Bye bye.